I've just completed a CUDA-accelerated transformer-based AI application capable of disassembling hexadecimal machine code into human-readable assembly language, trained from real DLLs and binary data extracted directly from Windows memory regions. This is not just another model. It's a real-time inference engine designed for deep binary analysis, modding enablement, and threat detection. Gamers and modders, unlocking new realms of control. This AI gives experienced modders the power to decode encrypted DLL routines from AAA games, reveal hidden game logic and hard-coded features within shaders, memory managers, and real-time rendering pipelines, expose previously inaccessible APIs and engine calls for audio, graphics, AI behaviors, and even multiplayer handling. Design new game mods directly from machine code without needing the original source or SDK, bringing a new era of AI-powered reverse modding. Modders who traditionally relied on guesswork, memory scanning tools, or assembly breakpoints can now translate hex dumps directly into readable and editable assembly, dramatically speeding up and expanding what's possible. For cybersecurity and network defense teams, security analysts and reverse engineers can use this AI to disassemble suspicious binaries or unknown DLLs from network traffic or unknown software, translate raw hex from memory dumps into meaningful patterns for threat signature generation, detect obfuscated or polymorphic malware based on patterns in assembly flow, opcode frequency, and API call chains, integrate with EDR, endpoint detection and response systems to classify machine code in real time, helping identify zero-day exploits. This changes the game for binary forensics, allowing you to automate early-stage malware analysis without manually stepping through millions of instructions. For systems engineers and developers, easily analyze compiled binary artifacts from compilers, optimizing for performance bottlenecks, register usage, and instruction flow. Train further models on code from different vendors, for example, NVIDIA, AMD, Intel, to understand GPU drivers, firmware blobs, and vendor-specific extensions. Augment debugging pipelines to include semantic insights from hex code, helping bridge gaps between source and compiled output. What powers it? Transformer seek-to-seek architecture trained on custom tokenized datasets. GPU accelerated with CUDA. Custom pre-processing pipeline extracting hex dumps, symbolic metadata, assembly instructions, ASCII representations, API and function addresses. The model is fully trained to map raw hex into logical, readable machine code instructions, and it can be used interactively via CLI or embedded into larger tools, e.g. IDA Pro plugins, security dashboards, or modding toolkits. What's next? Expanding scope from DLL level to entire OS-wide disassembly pipelines, scanning all .dll, .exe, and .sy files across a drive. Visualizing code graphs from hex dumps, enabling visual traversal of logic blocks. Creating an AI copilot for reverse engineering. Imagine uploading a DLL and chatting with an AI about what each segment does. In summary, this tool isn't just about reverse engineering, it's about democratizing low-level intelligence, giving gamers superpowers to mod and extend their favorite titles, equipping defenders to understand unknown threats faster, helping developers visualize and learn from the machine's own execution logic. We've reached a new milestone where AI understands assembly from raw binary code. Now it's up to us to decide how far we want to take it.